Hi, Ivan here. Today we're going to solve the diagonal difference problem. Given a square matrix, calculate the absolute difference between the sums of its diagonal. For example, the square matrix R is shown below. The left to right diagonal is 1, 5, 9, and it's 15. Then right to left is 3 plus 5 plus 9 is equal to 17. Then their absolute difference is 15 minus 17 is 2. Complete the diagonal difference function indicated below, and it takes following parameter: array, two-dimensional array with size n and m, and we must return the absolute diagonal difference. Let's take another example. Like this: 11, 5, and minus 12. It's it, and the sum is 4, and the secondary is 4, 5, and 10. 4, 5, and 10. If the sum is equal to 19, then 4 minus 19 is 15. So you solve it here. Let's store each diagonal sum from top left to right bottom and bottom right, and from top right to bottom left. The zero index is from top left to bottom right, and the second is from top right to bottom left. Then we iterate all the its line. Let's say then the from top left to bottom right is as a common, let's say, x and y coordinate on the first index and the second index. So let's say this is 0 and 0, this is the 1 and 1, this is 2 and 2. So we must sum to store it in the first index with r, e, comma, e, and e, or e. So it will, let's for example, for 0, it is 0 and 0, and if the I is 1, is 1 and 1 is 5. If the I is 2, is 2 and 2, which is 9. After that, the opposite diagonal from top right to bottom left, 3, 5, and 9 is set as a 2, 2 and 0 is a 1 and 1. This is the 0 and 2. So we the row, it will following the number of its row, the sequence of its row. Let's say this is is 2 and 0, then growing to 1 to 1, and growing to 0 to 2. The sorry, this is yeah. The first is the 3 is 0 2, second is this, and the third to row 2 column 1, column 0. This is growing ascending, and this growing descending. We can cover this. We can cover the first index. We just follow the I. Then the column or the second index, we can calculate it. Then with, let's say, his opponent is close to. So if the, let's say, the length is 3, let's say at the first element, 3 minus I minus 0, and that's minus 1 is 2. We get is 2. And well, the I is on the second row, or I is 1, then the length is 3 minus I minus 1, so 2. 2 minus 1 is 1, so it's get to 1, and so on. Then we just store it, E, and this component. Yes, we just click this. After that, we can return the, we must take the sum. I have this function. You can, this function made by myself. You can return the absolute value from with the integer, 32-bit integer data type. Types of sum. Let's run the code. We pass the first test case, and it passed all the test case. So the apps you can copy from my repository on GitHub. This is the apps. Now you can copy from this. This is made by myself. Actually, in the Golang package, on the math package, there is a apps function, but it has a float, so we must convert it to float first. But in this section, in this problem, we use integer, 32-bit integer. So I made it by myself using to get absolute value, but the parameter and the return is using 32-bit integer. So that's all. If you have any question or better solutions, write down on the comment section below. Thanks.